Notes 4.9. So this is called the discriminant. And we are going to tell you what is a discriminant. First of all, pause the video for a second and see if you can remember the quadratic formula. So I'm going to write the quadratic formula. X equals to find the roots of this. So actually, minus b plus or minus the square root of b squared minus 4ac. You should kind of memorize that all over to a. You should really know that formula. Okay. Now, this part right here under the radical has a special name. That part right there we're going to call the discriminant. And it's b squared minus 4ac. And if we find that piece just under the radical, maybe we don't have to solve the quadratic equation. Maybe the directions are something more like find the value of the discriminant, or how many answers are there, how many roots, and what kind of roots are they. Then you don't have to solve the whole thing. You don't have to do the whole quadratic formula, okay? So there are several cases here. Let's write them down and we'll talk about them in a little bit. But one of the cases is when d is a positive number, when we have a perfect square, when both of those are true, okay, we're going to have two roots, and they're going to be rational. Or if you're not so good, or if you get too confused, you can just say real numbers. But if you want to be more precise, rational would be great. Rational means fractional. Like, yeah, we can make a fraction out of it. Okay, so this other one, if it's not a perfect square under the radical, right? If the discriminant doesn't come out to a remember perfect squares? Perfect squares are like if you had 16 under there or 25 under there. Those were perfect squares, right, guys? Well, if you don't have any of those things under there, then and if you also have it positive number under there, if you end up doing the math and get a positive number, but it's not a perfect square, you're going to have, again, two roots, but they're going to be irrational. Okay, because you're going to have a square root of something, like you'll have a square root of 12 under there, and you can't, you can simplify it a little bit to 2 square roots of 3, but you can't simplify square root of 3. It's a decimal. So that in that case, you would have irrational root. You can just say real if you're too confused. Okay, if it's equal to 0 under the radical, like that, then the plus or minus, well, you don't have any plus or minus. It's plus 0, minus 0. So you would have, for example, if you had something like this, then you would have just 2 over 2. You'd have one answer, one root. If you got one root, it's real, and it would be rational. It means it can be like a fraction. So 2 over 2 is 1. 2 over 2, or 1 can be a fraction. If it's a negative number, then we have two answers. They were like, if you had negative 3 under there, then it was 3 times I plus or minus. There were always 2 of them, right? There were always 2, except for if you had 0 under there. You might remember. So this would be imaginary. Odd or complex. Okay, so find the value of the discriminant. So if I'm looking at this and I calculate, first I need to know what my ABC is. A is 2, B is 12, C is negative 13. Don't forget your negative numbers, guys. So you do B squared, 12 squared minus 4 times A number times C number. And you would calculate that out to what that equals. And you find out it equals like 200 and something. Try it on your calculator to make sure you can get the right answers. That is the number that tells us. Okay, that is nothing in itself, but it tells us it is positive. So I'll make it a different color for you. I'll make it blue. So it's positive. That means D is a positive number. So that means we're up here somewhere. So we know that our answer is going to be real. We could just put real. And we know that there's going to be two of them. So we could put 2 real. 2. Or is it a perfect square number? I don't think so. You can do square root of 248. It's not going to come out to an even number. You could try it, but it won't. So that's going to be irrational. Okay, because it's going to not break down into just a perfect square number. So -1, 16, -64, ABC, b squared, minus 4AC, okay, and we don't have to do the rest of it. So that's 256, I think, minus 240, 256 or something like that. No. Yeah, 256. 256. Wait a second. That ends up being 0. That's equal to 0. And so that is a really good thing because when we have 0, in this case, I'll do a different color. We'll do red. When we have 0 on this, that 0 is going to be telling us we have one solution and that it's a rational solution. So one solution and rational. Okay, so you should be able to do 3 and 4. If you do them correctly, you should get 1, 4, 4, 4 for that one. And 2 rational. I would double check it if I were you. And 2, you get 288 negative, I think, if I did it right. And that would mean 2 imaginary. Okay, so just a couple of things. There are different methods you can use to find the solutions to quadratic equations, and different methods you can use just to find the discriminant and all that. So I'd like to talk about choosing methods. Okay, when would you choose graphing? Well, graphing can be used. We don't usually use graphing. It's kind of harder sometimes. It can be harder to solve these that way. But for certain things where you have easy numbers, if they're integers, like -1, -2, if they crisscross at really nice numbers on the x-axis, really easy numbers, and maybe also if you need to know other things, vertex and other characteristics like end behavior. When x goes to -infinity, what's y doing, for example? Okay? When you need to know these other things, you would use graphing. Factoring's pretty easy, but you can use it sometimes. I'll say sometimes. I just put sometimes, always and always. Okay, so I'll put that there so you know there's a caveat there. So factoring. Well, again, when it's a equal to 1 trinomial, then you can see, does it factor easy? Okay. If it factors easily, then use it. Okay, good. You can do it. Square root. Remember the square root. You'd have to have something like this. Okay? If it was just the x squared term, okay. But if you had something like this, okay, you couldn't do the square root. This one you can do the square root of both sides, but this one you can't because you've got the x piece there too. That won't work because of the b term. Okay? So if you've got that b term there, which is, so you can't, no b term, then you can do the square root method if there's no b term. Okay, this says sometimes, I think. Okay, completing the square. That's the one where you get the twin. You need to know how to do that. completing the square. And completing the square was a real pain in the butt when a was greater than 1. So if a is equal to 1 and not easy to factor, you could complete the square. You also could complete the square to find a vertex, you might remember. Okay. So, yeah, I would say. But the b term should be b term even. Okay? The b term should be even. What do I mean by that? It's really important that you know that if you had something like this, plus 7x plus 3 equals 0, and I say, complete the square, or this one, which one would you rather complete the square on? The top one or the bottom one? And you should be thinking, it should be obvious to you now that the top one would be hard to complete the square, whereas this bottom one, because it's got an even number for the b term, 8, you divide it by 2, and then square it, you get 64. So you add 64 to both sides. So this one's easier to do it because it's an even number. That one's a pain in the butt. It would be 7 over 2, it would be 3.5, and you have to add 3.5 squared to each side. No. Okay, so completing the square, b term even. Quadratic formula, you can always use that. So I would say use often. But why would you use it? I just want to point out, why would you use it if you had something like this? Okay, if you got something like this, you should easily, very easily say, no, I don't need quadratic formula for that. I can actually do that with much easier, much quicker, and with less mistakes with factoring. And some of you aren't very good at this, so you really want to practice it. So you would just go, oh yeah, I don't need quadratic formula for that. I would solve that quadratic equation equal to 0. I would solve that by saying, oh, plus 2 plus 3, because those numbers multiplied together give you 6, but added together give you 5. And the answers would be -2 and -3. And you didn't need quadratic formula for that. So yes, use it often. But be careful that you're not using it for things like that. That you shouldn't. Come on. Okay? So A, B, C, D, we did these on the board. So equation A, B, C, D, it says find the discriminant. So if you do these correctly, you should end up saying that there's 2 imaginary. Whoops, I just messed up something here. 2 imaginary. Double check, see what you get for numbers when you complete these, okay? You have to do them the same way you just did the other side, b squared minus 4ac. That's all you're doing, and getting a number. 2 irrational, 2 rational, or real, and 2 irrational. Okay, so they should come out to these. Which one would I pick for factoring? I don't know. When I look at these, it says pick one for each. Use each method only once. So we need to see, like, for equation A, B, C, D, we need to see which one would be like easier or good to do with square roots, with factoring, with completing the square. So it looks to me like square roots is an easy one to think about because it said, remember, no B term. There's only one of those up there that has no B term. Which one is it? You should know. So I would say equation B, okay, because it doesn't have a B term. So I would use the square roots method. So minus 2x squared equals negative 144. Divide by negative 2, divide by negative 2. Right? So you get x squared alone. Don't forget plus minus, very good. Negative is a positive. I think you get 50, 60, 72. Is that right? Yeah, 72. And you would have to do 36 times 2. So x equals plus or minus 6 square roots of 2. And you have your answer. You solved it. You can even put these funky brackets around it, and that would be really cool. Okay? Quadratic formula, I would, pick something hard. I don't know. Let's pick for factoring. Let's take equation C. So if I did that, if I decided that, I don't think I could factor A or D. I can't find two numbers. So when I want to factor, I'm going to try to tell you that factoring A isn't going to happen because you're going to try to do this and you're not going to find two numbers that'll work, right? And the same thing with this one. Go ahead and try it. And if you find two numbers that work, hey, hell, go ahead and factor it. Get your two answers, right? Equals 0, right? But you can't, right? So if I'm telling you right now, you're not gonna. So the point is that I would pick for factoring something like, say, equation C. So do the AC method. AC method is this times this. 3 times 7, 21. 1 times 21, 2 times, or 3 times 7. Actually, I think 1 and 21 work perfect for me. What do I want? I want minus 22. If I want minus 22, I would have a minus and a minus, which multiplies together to give me the positive. And when I add them up, it would give me negative 22. So copy the beginning. How many times have we done this? A million, right? Minus 22 is the same thing as minus 1x minus 21x plus 7 equals 0. And I would boom, 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 boom. I would divide out or factor out. Since you already know this pretty well, I'm doing it kind of fast. You can slow the video. X, parentheses, 3x times x is 3x squared minus 1. Get a twin, 3x minus 1. What comes out in front? It looks like a negative 7, I think. Negative 7 times 3, yep, negative 21. Negative 7 times negative 1, yep, positive 7. So x minus 7 is one of my factors, and 3x minus 1, the twin, is the other factor. And if they're equal to 0, you know one of them equal to 0 gets you your answer. So x minus 7 equals 0, and 3x minus 1 equals 0. So x is 7, and x is 1/3. And you can put those into, and 7, into some funky brackets. Okay, so there we go with that. Completing the square. I'll take it with, I don't know, equation A. So why not? Equation A. Or D. It doesn't matter which one you choose. Actually, I'm going to take D. I don't know why I decided to change my mind, but I did. X squared plus 6x minus 15. X squared plus 6x minus 15 equals 0. Kick the 15 out of there. X squared plus 6x. Divide the 6 by 2. That's 3. Square it, you get 9. So I'm going to be adding 9 to each side. I already have 15 over there, plus 9 on both sides, right? So I've got 15, 24. And over here I've got, boom, boom, x plus what? 3, I think. And square root both sides. X plus 3 equals plus or minus 6 times 4, 2 square roots of 6. Minus the 3, x equals minus 3 plus or minus 2 square roots of 6. There's my two answers. Yay. Quadratic formula for C, I think it was, minus ABC for C. ABC is, no, what am I doing? Not C. A, yeah, my bad. A, all right. So for A, 1, negative 9, 21. 1, negative 9, 21, ABC. ABC. Minus B, plus or minus, square root, B squared, that'd be 81, right? 9 times 9. Minus 4 times A times C. A is just 1, so I'm not even going to write it. And that was 27. Was that right? 27? Double check my 7 there. No, it was 21. My bad. 21. Looked like a 7. There we go. 1. Okay, so all over 2 times the A number, which is just 2 times 1. So I've got 81 minus 84, negative something, negative 3. So I got square root of negative 3. I'm going to put it over here. I'm just going to write it with a different color. Negative 3, which is I times the square root of 3. Right? So I'm just going to write that down here. So I've got my answers, again, my x answers are 9 plus or minus. So I plus or minus I square roots of 3 over, what do we say, 2? Okay, so you could leave it that way if you want. I kind of told you I liked it better. 9 over 2 plus or minus I square root of 3 over 2. Or if you want to put the square root of 3 before the I, yeah, you can. Okay, so yay, we kind of got that. And solving quadratic equations by factoring, well, we'd have to get x squared minus 6x minus 7 equals 0, minus 7 minus 6, or minus 7 plus 1. Does that work? Double check me. X minus 7 plus 1. So x equals negative 7. I'm sorry, positive 7. Doesn't work. Equals 7. And what's the other x? Negative 1. Okay. So this is factoring, right? It says we should factor this. There's some pretty big numbers here, so you got a lot of work on this one to factor that one. But you can do it with the AC method. I'm not going to do it right now. It would take too much of my video. Square roots method. 10x squared equals 282. Take away the 2 is 280. Divide by the 10. X squared equals 28. X equals, take the square root plus or minus the square root of 2 square roots of 7, I think. Is that right? I think so. Okay. Negative 166, take away 50 more. So I'm at this one where I would have, am I using quadratic formula? Oh, I'm using square root method. Okay, my bad. Okay, so get rid of the 50, and it's going to give me 216, I think, which is a nice number. Okay. Half of that is 108. Is that right? That's why I said it's a nice number, because it's nice and even. Plus or minus I, because it's a negative under the square root, right? Square root of 108. 108 has 9, because 9 times something is 108, right? So, did I do it right? Did I miss something? Negative 108. 108 is 9 times... Oh, wait a minute. There's a bigger one than 9. 108. So, 9 times 12. But I think that you'd actually go up and find that 36 is in 108 as well. If you divide it by, 36, 3, right? Okay, so we end up with, sorry about that, kind of end of the day here, long day. Okay, so 6, because 36, square root of 36 is 6, right? Square roots of 3, plus or minus I times 6, or actually you would probably have 6I square roots of 3. That's what it would look like. Okay, something like that. I don't know, completing the square. So x squared plus 12x, half of the 12 is 6. So you get 36, 6 times 6, equals 7 minus 3 is 4. And we had to add 36 to both sides, right? So we got 40 over there. Right, and here we got x plus 6 squared. And so that's x plus 6 equals plus or minus the square root of 40 is 2 square roots of 10, right? And and x equals minus 6 plus or minus 2 square roots of 10. Right? So, looks pretty good to me. You could put bars around it if you want. That would be nice. Okay. So these are the kind of things that we have to be able to do. Quadratic formula, minus b plus or minus the square root of b squared, 4 times 4 is 16, minus 4 times the a number, times the c number, which is just 1. Anything times 1 is itself. I don't even need it. All over 2 times 5, 10. So 16 minus 20, negative 4. So x equals minus 4 plus or minus the square root of 16 take away 20. What's 16 take away 20? 4 times 5, 20, right? Negative 4, so that would be I to 2i, right? 2i all over 10, which is, I can divide everything by 2. Negative 2 over 5 plus or minus 1 over 5i. Yep, so here you'd have to get the 5 over on the left, so you know your A number is negative 2, your B number is 2, your C number is negative 5, right? But, so I think you guys can do this. All right, bye.